Let's recall the two different types of waves. First we have the transverse wave. Then we have the longitudinal wave. Now we will discuss the characteristics of waves. This is a transverse wave. You can see that there are four parts: the crest, the trough, the wavelength, and the amplitude. The wavelength is the distance between two corresponding parts of the wave. This can be measured either from the crest to the crest or from trough to trough. The amplitude is the maximum or highest distance the medium moves up or down from its rest position. Now the crest is the highest point of the wave. The trough is the lowest point of the wave. Here we have a wavelength. Above you can see a wave with a longer wavelength, and below you can see a wave with a shorter wavelength. Here we have the amplitude, and it measures from the equilibrium position to the maximum position. Consider the waves in the sea. The amplitude is the height of the top of the wave from the flat sea. In a longitudinal wave, it is a little different. So this wave is traveling in this direction. A wavelength is from here to here. Here we have a compression, and here we have a rarefaction. A compression is where the parts or the particles are close together, and the rarefaction is where the particles are spread apart. Now we are going to discuss the period of the wave. The period is the time for one vibration or oscillation or a cycle of a wave. So it is the time for one wavelength to pass through a given point. The SI unit for period is S for seconds. The period is the time for one complete cycle of vibration. When something happens repeatedly, we say it is periodic. For example, the period of the Earth to orbit the Sun is 365 days. The period of the day is 24 hours. And the period of a class at school is about 50 minutes. Next, we will move to the frequency of a wave. The frequency is how many waves go past a point in 1 second. So it is the number of waves per second. The SI unit of frequency is Hertz, or Hz. So as I said, the frequency is how many waves pass through a point in 1 second. Here we have one wave. In this example, we have 5 waves that have passed, so the frequency is 5. Frequency is given the symbol F and measured in Hertz. There is a very important relationship between the frequency and the period. Let's repeat. The frequency is how many cycles occur per second, while the period is the time it takes a wave to vibrate in one cycle. The frequency and the period are inversely proportional. So, the frequency is equal to 1 divided by the period, and the period is equal to the 1 divided by the frequency. Let's try a calculation. So if we have a wave that has a frequency of 0.5 Hertz, calculate the period t of this wave. Okay, so we can use the formula t equals 1 divided by f, or frequency. T then is equal to 1 divided by 0.5, which is given. The answer would be 2 seconds. Do not forget the unit. Now I want you to open back to page 38 of the student worksheets. This will summarize what we have done so far. Pause the video, try to fill out your table, then continue the video to check your answers. So here we will have a brief definition, the symbol and the unit in SI units. The amplitude is the maximum distance from equilibrium. The symbol for amplitude is a capital A, and the unit, since it is a distance, is measured in meters. The frequency is the number of cycles in 1 second. The symbol is a lowercase f, and the unit, or the SI unit, is the Hertz, shortened to Hz. The period is summarized as the time for one cycle. It is given the symbol capital T, and this is measured in s, or seconds, since it is a time. The wavelength is the distance of one cycle. This is given a special symbol, which is the lambda, which is a Greek letter. And it is again measured in meters since it is a distance. Now we are going to continue and complete page 38. Here we are going to deduce the formula for velocity of a wave. So if we recall back, the velocity is equal to the distance divided by the time. Look back at the table we just filled out at the top of page 38 and think of the values that we can use to replace the distance in the formula and the time. The distance can be replaced by the wavelength. And the time is always replaced by the period. So we can say that the formula can be replaced with V equals lambda on T, lambda being the wavelength and big T being the period. So what is the relationship between the lambda, the velocity, and the frequency? Remembering that frequency is equal to 1 divided by the period. Think about it for a while. Yes, we can say that the velocity is equal to lambda times the frequency. Let's try an example. So a wave has a period t of 0.2 seconds and a wavelength of 5 meters. Calculate the velocity of this wave. Here we must calculate the frequency before we can calculate the velocity. First we must use the equation or the formula F equals 1 divided by period. So we can say from the given that F is equal to 1 divided by 0.2. So when we calculate this, it is 5 Hertz. Then we use the frequency in the formula V equals lambda times frequency. So the velocity is equal to 5 times 5, which is equal to 25 meters per second. Don't forget that velocity is measured in SI units of meters per second. Now go back to the student worksheets to page 38 and 39 and examine the two waves A and B in the figure. So if we look at their amplitude, is the amplitude of wave A greater than, equal to, or smaller than that of wave B? Look carefully at the amplitude and decide. So the amplitude of wave A is actually greater than that of wave B. Now look at the wavelength of wave A and compare it to that of wave B. Is it greater than, equal to, or smaller than? Look carefully. Yes, it is equal to. The period of wave A, is it greater than, equal to, or smaller than that of wave B? The period is actually equal to that of wave B. Now we are going to compare the frequency of both waves and justify the answer referring to answer of the above part C in the previous question. Okay, so the frequency of wave A is equal to the frequency of wave B since they both have an equal period. Now we are going to compare the speed of waves A and B referring to the answers in the previous parts B and C. We can say that the speed of wave A is equal to the speed of wave B since they both have equal wavelength and period.